BILLVEZIERA'S best solutions, where we talk about mathematics and chemistry, and today we are talking about mathematics. This question was taken from a topic called velocity and speed time graph. The question reads, the diagram below shows a speed time graph of a 100 meters sprinter who accelerates uniformly for 3 seconds until a speed of 12 meters per second is reached. He maintains the speed for 7 seconds and then decelerates for a further 4 seconds and comes to a stop. This is the diagram. Of course, you pardon me, the question at last it was something else, but I've read it correctly. So this is the diagram, and the questions are as follows. Calculate the acceleration during first 3 seconds, retardation at the end of his run, distance he covered in the first 10 seconds. We start. First one, acceleration. This is the formula to find the acceleration. The symbol is A. So A is equal to V minus U over T. That is, acceleration is equal to final velocity minus units of velocity over time. Then we get our data here. Acceleration is what we are looking for. Final velocity we have it is 12. Units of velocity where we started from is 0. And the time was 3. Then doing calculations here, we find the acceleration to be 4 meters per square seconds. Then coming to retardation at the end of his run. Retardation is found by using the same formula for acceleration. The difference is that deceleration is negative and acceleration is positive. Yeah, so deceleration is what we are looking for, and the final velocity is 0 because we are coming down. Where we stopped from, V is 0, and where we started from, initial is 12 and T is 4. Then doing our calculations there, we find that deceleration is equal to negative 3 meters per square centimeter per square seconds. But remember, when we just say deceleration, then we mean negative of acceleration. So we remove this negative and we find that as an answer. Then on C, as C was saying, find the distance he covered in the first 10 seconds. So starting from 0 up to 10 here. Then when find the distance, we have to know the shape we have. This entire shape is a trapezium, and trapezium, we know to find that we use distance is equal to half h open a plus b close. So even if we cut it from here, we can still use this. We can still use the formula for trapezium, where a is the distance from here to that one, from 3 to 10, and b is from 0 to 10, and height is from here up to the 12. Then plugging this in our formula, height 12, a 7, b 10, then we get 102 meters.